Alright, so here we are at 1.3, our last section before our first quiz of the year. We've been talking about the segment addition postulate and distance on a number line, that sort of thing. But now we're going to look at when we have 2 points, we want to know the distance between them. They may be on a coordinate plane, like on example 1 and 2, or you may just have the coordinates. So what I'm going to show you is how to use the distance formula in case you haven't seen that before, or in case you've forgotten that. And then I'll also kind of show you maybe a little shortcut that'll help you with some of the calculations. So here's the distance formula. The distance between 2 points equals the square root of this quantity plus this quantity. Where are we getting all these numbers? X sub 2, x sub 1, y sub 2, y sub 1. Well, those are the x and y coordinates of the 2 points that you want. So here's -3, 4. That's left 3, up 4. You can just kind of ignore the blue and green for now. Just look at the red. Here's -3, 4. And then 2, -5 is right 2, down 5 from the origin. So if I want to know the distance between this red point and this red point, here, connect them. There's my line segment. I want to know the length of that line segment. So what you're going to do is label the x and y coordinates of the 2 endpoints. So you label x sub 1, y sub 1, x sub 2, y sub 2, and then you're going to substitute these values into the distance formula and solve. So x sub 2 minus x sub 1 is going to be 2 minus -3, see it? That whole quantity squared. And then y sub 2 minus y sub 1 is -5 minus 4. So following order of operations, we have to do the parentheses first. So what's 2 minus -3? That's 2 plus 3, gives me a 5. What's -5 minus 4? That's -9. Now this is an exponent, we're going to square this. 5 squared is 25. -9 squared is 81. It's not -81. Sometimes people will just type in -9 squared. If you're using a calculator and you type this in, that will give you -81. That's not what we want. Notice how we have parentheses here. So when we have parentheses -9 parentheses squared, if you're using a calculator, type that in exactly, because it's -9 times -9, which is positive 81. Now we add these two numbers. So we have the square root of 106. We can't reduce this radical, so this is our radical form answer. But if we asked you to round to the nearest 100th, you would just go to your calculator, you type square root of 106, and you get 10.30. Alright? So that's the distance from here to here. It's a little over 10. If you want to have a way to either check your work or just kind of a little shortcut, when you have the 2 points on a coordinate plane, what you can do is draw in a right triangle. So see how I went down and right to get from this point to this point? We'll count how much these are. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 1, 2, 3, 4, 5. And look at our two numbers that were squared here. 5 squared and 9 squared. Now yeah, that's a -9, but what's -9 squared? 81. What's 9 squared? 81. So you can, if you have the drawing here already in a coordinate plane, you can kind of do that as a little shortcut. Alright, so same thing over here. Here's 0, 7. Here's -4, 3. And you can label and substitute the values and get the answer. If you need to pause this at any time to write all this down, go ahead. For the next few sections of notes, they're already filled out, so if I'm going too fast and you don't have enough time, just pause the video, write down what you need to, unpause it, and keep going. So that's how you can use the distance formula for 2 points. Sometimes you have the coordinate plane to draw it on, sometimes you don't. If you don't have the coordinate plane here, you're going to do the same thing we did. X sub 1, y sub 1, x sub 2, y sub 2, and you're going to substitute it into here. So 3 minus 1, you're subtracting the x's. 1 minus 5, you're subtracting the y's. Do the parentheses first. This is 2, this is -4. Square the parentheses. When you square, you always get a positive. So this is 4, this is 16. What's 4 plus 16? 20. Square root of 20 is your answer. Here's the next one. Same kind of thing. Again, feel free to try that one on your own if you want, and then come back and check it. But there's your answer. And notice in this one, the square 289 is a perfect square. So when you do the square root of 289, you get 17. So these answers are the same. Right? This is the distance formula. This tells us the distance between any 2 points. In this section, we also have the midpoint formula. The midpoint of a segment is exactly in the middle. So the way that we find that is we're kind of like taking the average of the x values and we're taking the average of the y values, because we want to be right in the middle of the x and right in the middle of the y's. So look, here's C, -4, 2, right there. Here's D, right 6, up 2. I want the midpoint of CD, which we're going to call M. So how do I know where to put this? Well, the midpoint formula says I get the coordinates of the midpoint. Notice the midpoint is a point, so it's going to have an x and y. How do I get the x coordinate of the midpoint? I add the x's of the two endpoints and divide by 2. And then how do I get the y? I add the y's and divide by 2. So -4 plus 6 is 2. What's 2 divided by 2? 1. 2 plus 2 is 4. 4 divided by 2 is 2. So this is the coordinates of the midpoint. And look at it, it looks like it's right in the middle. Now notice this one might have been easier because since it's already horizontal, you can just count what is the length of CD. You can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If CD is 10 units long, the midpoint is going to be 5 from one of them. So you could just go to C and just count 1, 2, 3, 4, 5 halfway, and yep, there it is. That's not always the case when you have something like this where it's diagonal, where you need to know halfway between the x's and halfway between the y's. So here we go. Using the formula, you're going to go, here's A, here's B. I want to know the midpoint. So the midpoint coordinates are going to be the two x's added together and divided by 2, and the two y's added together divided by 2. Add the numerator first, then divide by the denominator. -2 plus 5 is 3. What's 3 over 2? 3 over 2, or 1.5. What's 3 plus -2? That's 1. So we have 3 halves and 1 half, which is 1.5 and 0.5. And there it is. Okay? You also could have said, well, how much did I go left to right from A to B? I go 1, 2, 3, 4, 5, 6, 7. So I only want to go half as much of that. So I want to go 3.5 to the right. And then how much did I go down from A to B? I went down 1, 2, 3, 4, 5, 6. So I'm only going to go down 3 to get to the midpoint. Excuse me, I actually counted wrong on that. There's the danger of it. It's actually 5. 1, 2, 3, 4. Go down 5, so you would go down 2.5 to get to the midpoint. Okay. Example 7, same thing. Again, if you wanna pause it, try example 7 on your own, then come back and check mine. Go ahead. Here it is. Now, this one is a little bit different. If you were able to try it on your own, good for you. In this one, we're going to give you an end point, which is A, and we're going to give you the midpoint, which is M. And we want to know the coordinates of the other end point. So instead of saying I know the two end points, like in 6, I'm going to add the x's, divide by 2, and add the y's, divide by 2 to get the midpoint. We're going to say I'm going to give you one end point and a midpoint. How do you get the other end point? Well, you still do the same thing. So I don't know what the coordinates of B are. So I'm just going to call them x and y, or x sub 2, y sub 2. This is what I'm trying to figure out. But I know that if I add the two x's of the endpoints and divide by 2, and add the two y coordinates and divide by 2, I'll get the coordinates of the midpoint. So here's how I set it up. I said the midpoint equals x, -1, plus the other x. I don't know what it is, so I'm going to call it x. and then I have to divide by 2, just like we did up here, right? Now I'm going to add the two y's and divide by 2. Well, this y is 7, this one I don't know, so I'm just going to call it y. So add the x's of the endpoint, divide by 2, add the y's of the endpoint, divide by 2, and that's going to equal the midpoint coordinates. Well, they told me the midpoint coordinates. It's 2, 4. So these coordinates here equal 2, 4. So this one is going to equal 2, so I set up this equation, and then this is going to equal 4, the y coordinate of the midpoint. Now I just solve. Multiply both sides by 2, add 1 to both sides, this is 5, multiply both sides by 2, subtract 1, this is 1. So here's the coordinates of the other endpoint. Now you could always check by saying, let's do what we just did in example 6. -1 plus 5 is 4, divided by 2 should give me the x coordinate of the midpoint. Yep, it worked. Now do the y's. 7 plus 1 is 8, 8 divided by 2 is 4, that's the y coordinate of the midpoint. Yep, it worked. If you don't like this kind of more algebraic way to think about it, what you can just do is double the midpoint coordinates and then subtract the one that you have. So let me show you. Let's do the x. Double the x. 2 times 2 is 4. Now subtract the x that they gave you. -1. So you're going to do 4 minus -1. Well, isn't that 4 plus 1 is, hey look, 5. I got it. Now do the same thing with the y's. Take the y coordinate of the midpoint, double it. 4 times 2 is 8. Take your new number 8, subtract your y that they gave you. What's 8 minus 7? 1. So this is what we're looking for. It's a little bit tricky. This is an example. This one is, something that people miss a lot on the first quiz and the first test. So if you think that you need more help with that, come back and watch this again. If you need a more in-depth explanation, come see me after school. Go to Math Resource during ATR. Make sure you understand it. Okay? Now, example 8 and 9 look very similar, right? Again, if you need to pause it, go ahead. Write all it down, and then we'll come back and explain. Here's what's happening here. In number 8, it says, find the measure of PQ. That's this. If the midpoint of PR is Q. So look, I labeled these two slash marks here to show PQ and QR are congruent. They have the same measure. And I'm going to label what they gave me. They said PQ is 9y minus 2, and they said QR is 14 plus 5y. So I label and I label. Well, if Q is the midpoint, think about it. If I say this is right in the middle, if the whole thing is, let's just make up a number, 10 units long, wouldn't this be 5 and this be 5? So these two are the same measure, right? They're congruent. Now, I don't know what PR is, but I know that no matter what it is, if this is the midpoint, these are congruent. So I just set this equal to this, and I solve for y. I get 4, and then I can just substitute that back in. Now, what do they want to know? They want to know PQ, so I'm going to take this 4 for y, plug it in here. 36 minus 2 is 34. There's my answer. So when they give me the two different expressions for things that I know are congruent, I set them equal and I get the answer. 9 is a little bit different though. 9, they told me again Q is the midpoint, and they told me that QR is 6 minus 3x, and they didn't tell me what this is, and they told me that PR, the whole thing, is 14x plus 2. Well, a lot of times we see people that, just set these two equal, just like they did in example 8. But you can't do that. These are not equal. If I told you PR was 10 and Q was in the middle, you would say QR is 5, right? So it would go 5 plus 5 is 10. You wouldn't say 5 equals 10. Part plus part equals whole, right? So what you're going to do is, you're going to say, okay, if I know this is in the midpoint, if these are congruent, this is going to be 6 minus 3x like they told me, so is this. So I label that, and now I do just like we did with the segment addition postulate, part plus part equals whole. So 6 minus 3x plus 6 minus 3x equals 14x plus 2. And that's our time, so check out the work there, get the answer.